Welcome back to Scholar Strife, doing some math. Today we'll be graphing simple rational functions. Basically a rational function has the form, well, it looks like this, f of x equals p of x over q of x. So basically it's a function over a function, a polynomial over a polynomial. So where p and q of x are polynomials, and q cannot equal 0. That's a q. And a hyperbola is a graph of a simple rational function. Whoop. Let's fix that really quick. Why is it doing that? Simple rational function that has two symmetrical parts. Called branches. Alright, so parent function for simple rational function. This is our y equals 1 over x, also known as our inverse variation. So if you remember from a while back, it kind of looks like this. And then like this. And then we have asymptotes on the x equals 0 and y equals 0. So we have a vertical asymptote at x equals 0, y equals 0 for a horizontal asymptote, which means the graph approaches but never touches those points. The domain is all real numbers except 0. Same thing with the range. And then -1/2, -1, 1, 1/2. So if you wanted to look at the general equation looks like this. Y equals a x minus h plus k. Okay. Your vertical asymptote is at x equals h. Horizontal asymptote at y equals k. Your a value still stretches, shrinks, reflects. H still moves everything left or right. Sorry for the handwriting. K moves everything up or down. So a horizontal shift for H and a vertical shift for K. So just to draw a general example, it'll look something like that. This is our vertical asymptote at x equals h. And then our horizontal asymptote at y equals k. And then it'll look something like that. Okay, let's do a real example. So first figure out what your A, H, and K is. So A is up top, which is -4. H is R. So it says x plus 2 here. So we're going to use the opposite value, -2. H has always been like that. And then K tells the truth, so -1. Then we go fill out our table here. So I like to use values around, well, I guess it doesn't really matter. You just plug in any old values, -4, -3. Ah, okay, now I remember. So you want to use 2 values left of your H and 2 values right of your H. So this is -1 and 0. So when I plug these in, if I plug in -4 in, I'll get 1. If I plug in -3, I'll get 3. If I plug in -1, I'll get -5. And I'll plug in 0, I'll get -3. And remember, -2 we cannot do because that is our vertical or horizontal asymptote, or vertical asymptote. So let's punch in these numbers here. -4, 1. -3, 3. So always start off by drawing your asymptotes first. So H is -2. So we go to -2 and draw a vertical asymptote. And then K is -1. So we draw a horizontal asymptote. There we go. So now we can see where our graph is going to go. Boom. Boom. And then down here, -1, -5, 0, -3. 1, 2, 3. So look at that. Boom. Oh, vertical asymptote again. X equals -2. Horizontal asymptote. Y equals -1. Range, all real numbers. Same with the domain. Except 0. Oh, sorry. Not 0. So our domain is everything except our H value. And our range is everything except our K value. Because obviously we have a 0 here for X. Alright. Let's go to the next page. So those are some simple ones. So let's look at not so simple. So if it's in this form, the vertical asymptote is x equals -d over c, and the horizontal asymptote is y equals a over c. So for the vertical asymptote, I said y because that would be when that's setting the denominator equal to 0. We can't have a 0 in the denominator, so that's where our vertical asymptote is. And our horizontal asymptote is y equals a over c. So let's do an example. So just if you want to put this in notes here, if we look at the denominator here, cx plus d, and you set it equal to 0, cx equals -d, so x equals -d over c. This is when it's undefined. Okay. Alright, example. So we have A, B, C, D. So C is the leading coefficient. It's not X, it's 1. Okay. So our vertical asymptote is at X equals negative D over C. So that's just negative 3. Horizontal asymptote is Y equals A over C, which is 2 over 1, which is 2. Our domain will be everything but our asymptote, which is negative 3. Everything but 2. Okay, then we just start plugging in things around our vertical asymptote. Think of it as our H value, but it's around our vertical asymptote now. So we're at negative 3. So I'm going to plug in no, I'm sorry. Here we go. Plugging in values around our vertical asymptote, which is negative 3. So I'm going to put in negative 4, negative 5, negative 6. And then on the right side of negative 3 is negative 2, negative 1, 0. So let's see how that goes. So if I plug in negative 4, I get 1. Okay, if I plug in negative 5, I'll get 1.125, negative 6, 1.22, and then negative 2.6, negative 1.25, 0, negative 1/3. And I'll get, so always start off with a vertical asymptote and horizontal asymptote. So vertical asymptote is at X equals negative 3. Negative D over C. Oh, sorry. This is actually a positive 3. So that's why my numbers didn't work. So let's restart here. So you want to use numbers around your vertical asymptote, positive 3. So to the left of 3, we have 2, 1, and 0. And then to the right of 3, we have 4, 5, and 6. There we go. So if I put in 4, I'll get 9. 5, I'll get 5.5. If I put in 2, I'll get negative 5. If I put in 1, I'll get negative 1, 1/2. If I plug in 0, I'll get negative 1/3. If I plug in 6, I'll get 13 over 3. 13 over 3 is 4.33. So 4 1/3. So sorry about that. So yeah, before I put in, so it's opposite of D, so D is negative 3, so opposite of D is positive 3, and then over positive 1 is still 3. So if I plot these, you start off with your vertical asymptote, which is at positive 3. So 1, 2, 3, make a vertical. Oh, what's going on? Back. Discard. Okay. Vertical asymptote. Sorry about that. And then a horizontal asymptote at Y equals 2. There we go. Plot in our points. So if I plug in 0, negative 1/3, so just a little bit under 0. Plug in 1, I get negative 1.5, which is down here. And then plug in 2, I get negative 5. So as you see, it's doing something like this. And then 4, 5 is 6. 4 is 9, so that's all the way up here. 5 is 5.5. And then 6 is 4 1/3. So it's doing something like this. And there we go. So So let's do another example without any hiccups this time. So, remember, vertical asymptote equals x equals negative d, or opposite of d, over c. And remember, this is a, b, c, and d. So d is negative 2, so the opposite of negative 2 is positive 2 over 4, which is 1/2. Horizontal asymptotes is a over c, which is y equals 2 over 4, so that's still 1/2. I'm going to just quickly draw those in instead. So 1/2 1/2 okay, everything but 1/2, everything but 1/2. Okay. And then I'm going to plug in values around 1/2, I guess. Let's just use some easy ones. 1, 2, and 3. That's above 1/2. And then below 1/2, 0, -1, -2. And I'll get 1.5. If I plug in 2, I'll get 5 over 6. 7 over 10. Plug in 0, I'll get -1/2. So this is a 10. This is -0.5. -1 is 1/6. And -2 is 3/10. So I'm going to plug in 1. I'll get 1.5, which is right here. 2 is 5/6. So just a little bit above, a little bit below 1 there. And then 3 is 7/10. So we got this going on. And then 0 is -0.5. Oh, down here. -1 is 1/6, so barely touching there. So we're going this. Okay. Allocation problems. Use what we learn. A 3D printer builds up. Actually, I'm missing a question, but I'll just put it in there. 3D printer builds up layers of materials to make three-dimensional models. Each deposited layer bond to the layer below it. The company decides to make a small display models of engine components using a 3D printer. The printer costs $24,000. The material for each model costs $300. Write an equation that gives the average cost per model as a function of the number of models printed. So the average cost over the number of models is 24,000 plus 300. So you gotta buy the printer, and then each of the models costs $300. So 300 times the number of models divided by the number of models. And then graph the function using a graphing calculator, and then use the graph to estimate how many models must be printed for the average cost per model to fall to 700. Okay, so let's go to our graphing calculator. Follow us, please. Lab it. Hello. Y equals, and then we go down to, let's erase all this, 24,000 plus 300x, and then I forgot to put this in parentheses. Yep, gotta put in parentheses. So put it in parentheses. Divided by number of models. And then we go to graph. Probably not going to see much because I'm using a different window. Wait for it to load. And then we're going to go to zoom. All the way down to fit. Hit enter. That's much better. And then I'm going to hit trace. So when there's 12 models, there's 2,220. And we want to know when it goes down to 700. So looks like if I put in 30. Oh. So my window is terrible. So let's say 30 to 100. So the reason why I'm using these numbers is because I saw it was going down the farther we increase the number of models. And then our Y value, we're looking for 700. So let's just say 500 minimum and 900 maximum. And then we'll go back to the graph. Okay. Now I'm going to go to trace. And let's say, 65 is 669. Let's go to 60. 60, well, 700 on the dot. So, back to our equation. How do we get out of here? So graph the function using graph calculator, which is what we did, and find out when it reached 700. And that was around 60 models. And then there was a third question here, which was what happens to the average cost as more models are printed. Goes down. So as more models are printed, the average cost goes down. Because if you only made one model, that's a very, you bought an entire printer just to print one model. But if you build 100 models, the average cost of each model goes down. Okay. And that's it for this section. Just graphing simple rational functions. Hope this helps you out. Have a good day.